Hello everyone. This is third video on quicksort. In this video we will see the partition function of quicksort in detail with an example. I have referred the book Introduction to Algorithms by Thomas H. Corman and other authors for this example. The figure on the right side shows the cases which are possible while applying the partition function on given array and tell us what actions should be taken if these cases occurs. Actually, these two cases possible as shown in figure, case A and case B, there are two cases possible. Here the figure shows some intermediate stage after a few iterations in the partition function. As I told you in last video that P is the first index, R is the last index, the element at index R is the pivot element. Variable I works as wall between the two partitions. First partitions contain the values less than pivot element, and second partition less than or equal to pivot element, and second partition contains the elements greater than pivot element. Okay, now focus on variable j. J here works as scanner, which scans from left to right and decides whether to put an element in the first partition or in the second partition. In this figure, J has not scanned all the elements. Some elements are left. The elements from J to R-1 are still left. J has already divided the scan element into two partitions, from P to I and I plus 1 to J minus 1. Now look at the next element at index J. If it is greater than pivot element X, then it should be in the second partition. So in this case we will just increment J to the next position so that the element is automatically included in the second partition. But if the element at index J is less than or equal to pivot element X, which is second case, in this case this element at index J should be in the first partition. So what we do here is we first create space in the first partition by incrementing I. We have incremented I to one position right, and then swap AI and AJ and AI. In this way we bring that element in the first partition. Now J have to check the next element, so we increment J also to the right. J is incremented to the right position. Now look at this example. In this example, pivot element is 4. We have initialized I to P minus 1. We have initialized I to P minus 1 because J has not scanned any element yet. J is initialized to first index P. The element at J is 2, which is less than 4, the pivot element. Therefore, it is the second case because 2 is less than 4. What we did in the second case is we have to increment I and swap AI and AJ. Here, if we increment I to this position, I and J will be at same position, so swapping is not visible. 2 is swapped with itself. After this, we have to increment J, so we incremented J. Now next element at J is 8, which is greater than pivot element 4. So it is first case, we have to just increment J one position right. Now next element is at index J is 7, which is also greater than pivot element 4. So in this so it is again first case, and we have to just increment J to the one position right so that 7 is automatically included in the second partition. This is the first partition, this is second partition. Now next element is 1, which is less than 4, the pivot element. Therefore it is the second case. 1 should be in the first partition, so we incremented I first, and then and swapped 1 and with 8. So 1 is here and we have incremented I. Now next element at index j is 3, which is again less than 4, the pivot element. So we have to increment again I and swap 3 and 7. So 3 is at this position, and we have 7 is at this position. Next we move j to one position right, because j have to scan the next element. Now next element is 5, which is greater than pivot element 4. So in this is the first case. In this we have to just increment j. So we have just incremented j, and 5 is automatically included in the second partition. The next element is 6. It is again greater than pivot element 4. So we just increment j to the one position right, and it is 6 is automatically included in the second partition. After the iterations complete, we have to bring this pivot element in between these two partitions. So we swap 4 and 8, and 4 comes in between these two partitions. And after that we return the new position of pivot element 4, which is next to the right. That is, we return I plus 1.